Okay, let's still go through a couple more examples of simplification right here. Simplification requires that we look for common factors in the numerator and denominator that can be reduced. And as a matter of fact, we have actually done something similar to this particular expression in the past when we're talking about dividing polynomials. All we really have right here, at least in this case, is a common factor. But I'm going to go through it just slightly differently and note that in the numerator we have an expression that contains a common factor. And that common factor happens to be negative 9, because 9 divides into 9, 18, and 27. And I'm actually going to make it negative 9. And a squared, which is also a common factor to all three terms in the numerator. And we factored out, we say, well, negative 9 times a squared times what gives me negative 9a to the fourth? And that would be positive a squared. Negative 9a squared times what gives me negative 18a cubed? That would have to be plus 2a. And negative 9a squared times something gives me 27a squared, and that happens to be plus 3. And when I divide that by negative 9a squared, in this idea, we see that we have a common factor of negative 9a squared, so we can divide that one by the other. It leaves us a denominator of 1, and we would say that this expression, a squared plus 2a plus 3, is the equivalent as long as a does not equal 0. We have to ensure that the domain of the original expression matches the domain of the resulting expression. And so we would want to ensure that a does not equal 0. It might be helpful if before you begin reducing anything that you find the domain of the original expression and just take the time to write out that domain. And our domain here in this expression, this is a simple one, but the domain is all x such that x, not all x because we're dealing with a, so we need to check here, all a such that a does not equal 0. I'm going to give the off chance of giving some extra bonus points. Heaven defend. Okay, well, let's try the next one here. We've got x cubed minus 3x minus 28 over x squared minus 4x plus 32. Before you start trying to take out x's, please remember the following. You cannot, that's a terrible way to spell cannot. Let me try that. Cannot, C-A-N-N-O-T. You cannot cancel common terms. Only common factors. Be very careful. This is one place that people tend to forget because they don't take their time. Cancel common terms. You can only cancel common factors. Common factors. Okay, very important to remember. So what we have to do is that if we're going to simplify this expression like any other place, we have to simplify our expression by factoring first. So let's look at our factors of our numerator. We've got x squared minus 3x minus 28. We know that the first term in these binomials is going to be x to give us x squared. And we need two factors of negative 28 whose sum is negative 3, and that would be negative 7 and positive 4, whose product is negative 28, and whose sum is negative 3. And look at our denominator. Again, we want to find two factors, binomial factors that are going to start with x in each case. And how about that 32? Well, we need two factors of negative 32, whose sum is negative 4. It happens to turn out that that is negative 8 and positive 4 this time. And so positive 4, x plus 4, is a common factor. So we can cancel that, and as long as we remember that our reduced expression, x minus 7 over x minus 8, will be equivalent as long as x does not equal negative 4. Okay? So this last bit right here, where I'm writing x does not equal negative 4, must account for the factor that gets canceled out. And write canceled by division, because that's what we're doing. We're dividing out that term, x, that factor, x plus 4, right? And that would make our original expression have a denominator of 0. So we have to state it out right here, since it's no longer implied by the denominator. Note that x cannot equal 8 is implied as part of the domain. Okay, so we don't need to state the implied domain. We just need to state the part that's changed. That is, we need to say that x cannot equal -4 in order to make this all work. Okay, more in the next video.